Resistors are one of the most common components of electronic circuits. They limit or resist current flow. Resistors come in different shapes and sizes and are produced in a variety of forms. They can be through-hole or surface mount. You may ask, what is the difference between a surface mount device and a through-hole device? Surface mount devices are components that are mounted or soldered directly onto the surface of printed circuit boards. It is generally difficult to pick up and place surface mount resistors with fingers, so you can use tweezers for this purpose. On the other hand, through-hole components are having leads which are inserted into holes that are drilled in printed circuit boards and soldered to pads on the opposite side of the board. Here you can see different types of resistors I have in my lab. There are a variety of other types available. You can search electronic component suppliers to find the proper resistor for your own project. We can classify resistors into two categories, and each of these categories are subdivided into more. You may find other types of classifications. I don't want to get into the details. Just have this tree diagram as a reference. To measure the value of the resistance by using a digital multimeter, turn the function selector to the resistance setting and connect the probes. Then connect one probe at each lead of the resistor you intend to measure and read the indicated value. There are some points you have to keep in mind when measuring a resistance value. You have to remove power from the circuit before measuring resistance. Applying voltage to the probes when the resistance function is selected may damage your multimeter or result in personal injury. If the resistor you intend to measure is soldered on the PCB or it is connected to other components on the breadboard, disconnect it from the circuit before measuring the resistance value. You intend to measure the resistance of your resistor, not the resistance of the circuit. Do not hold the ends of the resistor in your hand because your body has a resistance and you will measure the parallel combination of the resistor and your body's resistance, which will result to an incorrect value. This is very important, especially when measuring high resistances. As an example, I have a 3.3 mega ohm resistor. If I measure the value without touching the leads, the multimeter shows a value around 3.3 mega ohm. But if I touch the leads, the measured value will also include the resistance of my body, which is definitely a wrong measurement. If I touch the multimeter probes with my hand, it will show the resistance of my body. To measure resistor values by using myDAQ, connect the probes and the USB cable. In your computer, open NI-LVSMX Instrument Launcher and from the Instruments and Apps section, click on Digital Multimeter. Select the resistance function. You can make it auto-range so that it will automatically detect the proper range or choose a specified range and manually select the proper range. As an example, if I intend to measure a 3.3 mega ohm resistor by using a manual range, I have to select the 20 mega ohm range. By pressing the Run button, myDAQ operates like a digital multimeter. If I select Run once as acquisition mode, the device will measure the resistance once and holds the value until I press the Run button and make another measurement. All resistors have a tolerance, so the actual resistance of each resistor will deviate a little bit from its nominal value. For example, the actual value of a 3.3 megaohms resistor with 5% tolerance lies between 3.135 megaohms and 3.465 megaohms. We have to use a multimeter to measure the accurate value. But if you have a shelf with lots of resistors and you intend to quickly pick some resistors, you should be able to identify the nominal value of your desired resistor in case you don't have access to a multimeter. In this case, you need to be familiar with through-hole resistors color code. We have 4-band and 5-band color codes. Let's begin with 4-band code resistors. In 4-band code resistors, the first two color bands are significant digits. The third band is a multiplier and the fourth color band is the tolerance. As an example, in this resistor, we have 4 color bands. The first band is yellow or 4. The second band is violet or 7. Since this is a 4-color band resistor, the third band is a multiplier. So we multiply this number by 10. The result will be a 470 ohm resistor. The fourth band is the tolerance. Therefore, the actual value of this resistor can deviate from the nominal 470 ohms by 5%. Let's take a look at some other examples. 5-color band resistors are more precise and generally more expensive. In 5-band code resistors, the first 3 color bands are significant digits, the fourth band is multiplier, and the fifth color band is the tolerance. As an example, in this resistor, the first color band is red or 2, the second band is blue or 6, and the third band is brown or 1. The fourth band, which is the multiplier, is black, so we have to multiply the result by 1. The fifth band, which is the tolerance band, is brown. So this resistor is 261 ohm resistor with 1% tolerance. Take a look at some other examples. The color-coded carbon film resistors I use in this course are mainly 0.25 watts, unless stated otherwise. Resistors with higher power ratings are physically larger and may require heat sinks. As an example, compare the size of these two 470 ohm resistors. The one with the higher power rating has an obvious bigger size. These two resistors are wire-wound ceramic cement high-power resistors. As you see, there is no color code. The value of the resistors and their power ratings are written on the resistors. As an exercise, what is the value of this resistor? This is a resistor with only a single black color band. I believe that you have found the correct answer. This is a 0 ohm resistor. It is also called a 0 ohm link. Since its value is 0, it wouldn't make sense to have a tolerance band. You may ask, what is the use of a 0 ohm resistor when it behaves like a piece of wire? Imagine you have a single-side printed circuit board and you intend to connect two components together, but there is no way to create a trace without contacting with other traces. Here you can use a 0 ohm resistor to cross another root or trace without having a contact with each other. You may think of using a jumper instead of a 0 ohm resistor, and you are right. You can use a jumper, but in the fully automated process of PCB creation, you require a separate machine to pick and place the jumper on the PCB. This will increase the overall cost of PCB assembly. For SMD resistors, we have 3- and 4-digit systems. In a 3-digit system, the first two numbers are significant digits and the third one is the multiplier. In a 4-digit system, the first 3 numbers are significant digits and the fourth number is the multiplier. The 4-digit system is for more accurate resistors. The letter R represents a decimal point. For example, 5R1 is a 5.1 ohm resistor. R33 is a 0.33 ohm resistor, and so on. Sometimes, due to space constraints, manufacturers use an underline instead of writing the letter R at the beginning. There is another coding method for SMD resistors, which is EIA96 system. In this coding system, the first two numbers are significant digits and the third one is a multiplier. You have to keep in mind that the numbers you see on the resistor are codes. You have to refer to the EIA 96 table to find the value of the resistor. For example, for a 76X resistor, we refer to the table. The first two digits is code 76, which is 604, and the multiplier X is 0.1. So the value of this resistor is 60.4 ohms.